So in this session, we are going to discuss about super mesh analysis. So first, I will explain you why we are going for super mesh analysis. So generally in a circuit, so while applying the mesh analysis, we will write the closed loop equation by applying the Kirchhoff's voltage law. We will write the voltage drop across each elements by applying the Kirchhoff's voltage law. So while if we are having a current source in any of the branch, it is difficult to write the unknown voltage across the current source. So there is a difficulty existing in the normal technique. So we are going for super mesh analysis. For example, if you are having a current source linking any two branches, at that time there is a difficulty in applying the conventional method. So we are going for super mesh analysis. For example, you consider this circuit. So contains a voltage source. So it's a three loop circuit. We are having a resistance R1, R2. So in this branch, if you are having a current source, for example, you take this current source magnitude is I. Second loop is formed between the two branches. So finally, we are having a resistor R4. So in this case, by applying the Kirchhoff's voltage law, writing the equations will be slightly difficult because we don't know the voltage existing across the current source. So it will be slightly difficult to write the equations. For that, what we are going to do is the super mesh is formed between the first and second loop. For example, you take this as mesh or loop 1. I am assuming the mesh current as I1, mesh current as I2, here mesh current as I3. So here super meshes formed between mesh 1 and mesh 2. So, uh, so super mesh is formed between the mesh and mesh 2. So writing the equations directly, it will be slightly difficult. So we are going to write the equation for this loop 3. So writing the equation in loop 3, there is no problem because it's not having any current source. So directly we can apply the Kirchhoff's voltage law for loop 3 or mesh 3. So we can write the equations directly. So while writing the equation, we are assuming the sign plus minus. So current always flow from higher potential to lower. So we are writing this voltage drop as minus R3 into I3 minus I2 minus R4 into I3 is equal to 0. So we have written this equation. So rewriting this equation, we are getting R3 into I2 minus of R3 plus R4 into I3 is equal to 0. So this is the first equation. So next we are going to consider the branch where we are having the current source. So first we are going to ignore this branch where we are having this current source. Combinedly, we are going to write this equation. So combining the combined equation for for mesh 1 and mesh 2. So we are going to write the combined equation. We are by ignoring the branch we are getting this current source. So you take this circuit. So we are writing this equation combinedly V minus. So here we are going to assume the potential drop. So minus R1 into I1. So writing the voltage drop for this. So we have to neglect this. Okay. So combinedly we are writing. So next we have to proceed for writing for this branch. So minus R3 into I2 minus I3 is equal to 0. So we are completely ignoring this branch. We are writing the voltage drop existing by combining these two meshes. So now we are going to rearrange this equation. So we are simplifying this V minus R1 I1 minus R3 I2 plus R3 I3 is equal to 0. So shifting this term to the right hand side, we are getting R1 I1. So here we can write plus R3 into I2 minus R3 into I3. So I'm shifting all this term to the right hand side. I'm getting this equation 2. Okay. Then finally, where the branch we ignored, now we are going to consider that branch. Finally, we are writing that equation. Okay. So while writing the equation, directly we are going to write the current equation by taking this I1 I2 because both the currents will be flowing in this branch. So I1 current is same as that of this direction current action I, but I2 is opposite to the direction of I. So we are writing I1 minus I2 is equal to I. I1 minus.